In this video, we'll try to learn how do we calculate admittance matrix for a given simple system. So we have selected a 3-bus system here where there are 3 transmission lines. Now consider that each and every transmission line is represented by a pi representation. So now when we say that a line is represented by a pi, then on the right hand side you can see that the transmission line is represented by a pi network that has a series resistance and reactance and also the shunt susceptance. Now if you are trying to calculate an admittance bus matrix, then you wanted to write all these values in terms of admittances. So the series resistance and reactance, actually you will have the line related resistance and reactance as R plus jx of the line, but you will get your value of that admittance y12 as the inverse of line impedance. Now when we have mentioned that y12 is the admittance of the line, that is actually the inverse of the impedance of the line. And again you also have the shunt susceptance of the line. Now the susceptance of the line is YSH. This is what is the total susceptance of the line, whereas you wanted to have that being represented in pi, where half will be at the sending end, half will be at the receiving end. So now this is what is the pi representation of every line. If you wanted to find that admittance matrix for this network where every line is an equivalent pi, then you try to replace every line in this network using that pi representation. If we do that, the network is going to be something like this. So we have represented the first line using pi, and the second line using pi, and also third line using pi representation. And now this network can be further simplified using the following equations. Now what do we do is that in this particular pi network, if you look at this particular bus 1, now you see that this shunt element of this line as well as the shunt susceptance of this line, which are connected at this bus, are in parallel. So we can add this susceptance we have here and also this susceptance that we have here, and then get the total susceptance that is available at this bus number 1. So that's what we are writing here as y10 is nothing but the sum of the susceptance for the line 1 as well as the sum of the susceptance of the line 2. So y10 you will get, so then you can remove all the 2 susceptances that we have at these 2 points, then get only 1 susceptance instead of that. Similarly, if you look at the second bus, we have susceptance of the line 1 and line 3 being represented here half and half. So if you add the susceptance of the line 1 and line 3, then you will be getting the susceptance to be connected at your second bus. Similarly for the third bus. Now after simplifying this particular network, then we will be able to calculate our admittance matrix using these particular steps. So now you need to understand that from the summary of the admittance bus matrix formation, the size of the admittance bus matrix will be same as the number of nodes in our system. So in total we have 3 number of nodes in our system or 3 number of buses in our system. So the size of our admittance bus matrix will be 3 by 3. And then after that, if you want to get the diagonal elements of your admittance matrix, it is going to be the sum of all admittances connected at this particular bus. That is, if you want y11, the diagonal element, then it is the sum of y10, y12 as well as y13. Another diagonal element, if you want y22, then go for the second bus, then add all the susceptances connected at this bus. That is y20, y12 and y23. And if you want third diagonal, then we'll be adding all the 3 susceptances connected at this bus. That's what is the rule number 2 says. And the third thing is, how do we get the off diagonal elements of your admittance bus matrix? That is very simple. If you want off diagonal element corresponding to the bus 1 and bus 2, then it is just the negative of the admittance we have between 1 and 2. So if you follow that notation, then the admittance bus matrix for the network that we have here is given here. Now, in fact, this admittance bus matrix is something that is relating the currents injected at every bus with referred to the voltages at the buses. So that's why if you try to put it in an actual relation format, that is where you will be able to write your admittance matrix. So Y bus that you get is the first diagonal element and second and third diagonal elements. You can see that the first diagonal is sum of all the admittances connected at bus 1. Second diagonal is sum of all the admittances connected at bus 2. Third is sum of all admittances that are connected at bus 3. Now, if you want 1, 2, this particular element is nothing but negative of the admittance connected between 1 and 2. And this 1, 3 is also the negative of the admittance connected between 1 and 3. So that's how we get our admittance bus matrix. Along with that, the one more point that you can note from this admittance bus matrix is if you add all the elements in your first column, you will get the value as Y10. Similarly, if you add all the elements in your second column, then you will get Y20. And if you add all the elements in the third column, then you will be getting Y30. That means the sum of elements in a column, or even if it is a row, will give us the value of the shunt susceptance connected at a bus. That means your first column is related to bus number 1, or your first row is related to bus number 1. When you add all the elements in that particular column, then you are getting the value of the shunt susceptance that we have at that bus number 1. Similarly, for the bus number 2 and also bus number 3, that's how we'll be getting the shunt susceptance. So this is how we'll be calculating the admittance matrix of a given network. If you want to solve an example problem on the formation of the admittance bus matrix, let us consider that you have the same 3-bus network where you are given an information about the susceptance of each line is J0.02, while the series impedance is given as J0.1 here. Now, what you are given is for the shunt susceptance is available, but the series impedance is given. So in order to get admittance bus matrix, we need to first change that series impedance into an admittance. If you do that, then you will have that admittance of the line as 1 upon J0.1, which is minus J10 for us. So now after that, now you have all the admittances available in terms of series components as well as the shunt components, then populate them on the system. Then all the series admittances for the 3 lines, we have it as minus J10 because we have an information that all the 3 lines are identical. And whereas the shunt susceptance is given as J0.02, so now that J0.02 has to be half on the beginning of the line and half in the end of the line. So that has to be populated for all the 3 lines that we have in the 3-bus network here. Now after representing all the admittances in the network, then you can form or calculate your admittance bus matrix where the diagonal elements, let's say you want Y11, it is actually the sum of Y shunt elements that you have there. Now you can find the equivalent of those two J0.01s at bus number 1, or else you can add that values of the admittances as YSH for the first line half and YSH for the second line half, plus the values of Y12 and values of Y13. So this is what will be equivalent to J0.01 plus J0.01 for us, and this is minus J10 and minus J10. This is where you will get it as minus J19.98 as the first diagonal element. Similarly, you can see that this particular network is an identical network where the second bus is similar to the third bus and also the first bus is same. So your first diagonal element will be same for the second and third buses. Now if you wanted to get the off diagonal elements in your admittance bus matrix, then corresponding to that 1, 2, this particular element is nothing but the negative of the admittance between bus 1 and 2. Now, between bus 1 and bus 2, we have minus J10 as our admittance. So what comes here is negative of that minus J10, that is J10. And between 1 and 3, if you look at that, we have minus J10 here. So negative of the admittance between 1 and 3 is nothing but J10. So that's what is going to come up here. So that's where it will be very easy for us to calculate the admittance bus matrix once you have all the numbers in your network being represented as admittances itself. So the one thing to be very careful is sometimes you will be given impedances. So that impedances has to be first converted into the admittances. Then you can start calculating your admittance bus matrix.